All right, welcome. What I'm going to do here in this video, this is not a set of notes for this video. What I'm going to do is I'm going to go over the solutions to the two back problems for the classwork that we did in class today on Wednesday, and that's this one. So if we look, it says in 2000 the population of Massachusetts was 6.3 million people and was growing at a rate of about 0.32% per year. At this growth rate, the function f of x will equal 6.3, so that's the 6.3 million that we're starting with, times the growth rate 1.0032 to the x power. Gives the population in millions of x years after the year 2000. So that means every year we go after 2000 is an x value. So if it was the year 2001, x would be 1. If it was the year 2002, x would be 2, not 2002. That would make it grow away too much. So we want to know, using this model, find the year when the population reaches 7 million people. So we have our original function, f of x equals 6.3 times 1.0032 to the x power. What does 7 million people represent? Well, 7 million people would be what f of x equals when we're at some particular year. So we're going to put that value in, 7 equal to 6.3 times 1.0032 to the x power. And now we want to solve for x. So how can we do that? Well, first we need to move this 6.3. So we're going to divide both sides of the equation by 6.3. And we end up getting like 1.111111 repeating. So we'll just we will just round that off to 1.11 equals 1.0032 to the x power. Okay. So now we want to solve for x. Question is how? Well, if you want to get rid of an exponent, if you want to remove an exponent from a number, you have to use natural logs in order to do that. You'll find that that is a button on the calculator right there, natural log ln. And to do that, we need to take the natural log of, it's kind of like anything else that we do in math. Whatever we do to one side of the equation, we have to do to the other. So I'm going to take the natural log of 1.11, and that is going to be equal to the natural log of 1.0032, and that allows us to remove x. So now x just becomes a variable, not an exponent. So now I can just divide both sides of the equation by the natural log of 1.0032. And if I do that, I'm going to find that x equals, let me do this really quick. So natural log of 1.11 divided by the natural log of 1.0032, and that gives me like 32.66, and then it just kind of repeats on and on. So if we want to get to 7 million people, x needs to be about 33 years, which means it's going to be the year 2033 when the population finally reaches 7 million people. Okay, it'll actually reach 7 million people a little bit before the year 2033, but it's going to happen partway through between the year 2032 and 2033. Now, for this question down below, a ball is rolling down a slope and continuously picks up speed. Suppose the function f of x equals 1.2 times 1.11 to the x power. It's supposed to be to the x power. Describes the speed of the ball in inches per minute. How fast will the ball be rolling in 20 minutes? So, since we're talking about the speed of an object over time, that means x is time and y is speed. which is a pretty typical relationship. So that means if we're using our equation, f of x equals 1.2 times 1.11 to the x power, that means we want to find f of 20, when that's going to be equal to 1.2 times 1.11 to the 20th power. And if we solve for that, so let's see, 1.11 to the 20th power times 1.2 equals about 9.67. I'm rounding it. Let's see, what do we have for speed? Inches per minute. And that is our speed for that function after 20 minutes as it gradually picks up speed.